Hi, this is Mr. Ricks, and I'm gonna take you through some empirical formula problems. Reminder: the empirical formula is the lowest whole number ratio of atoms in a given formula. So, for this first example, we have 1.4 grams of sulfur and 2.10 grams of oxygen. So all we're doing to find the empirical formula is taking the mass and dividing by the mass on the periodic table. So we have 1.40 grams of sulfur divided by the mass of sulfur on the periodic table, which is 32. And then we do the same thing for oxygen. Take the mass of oxygen, 2.10, and divide it by the mass on the periodic table, which is 16. And the answers we get for this: 0.044. The answer we get here is 0.13. We could say 131. Okay, and then once we have that, we divide each by the lowest value. So the lowest value is this top value, so we divide it by. So 1 is always going to come out to be 1, and the other one is going to come out to be some ratio to 1, and so we get 0.044, and this is obviously, I want to make that an equal sign. This comes out to be 1, and this one comes out to be 2.98 approximately, which we will round up to, say, 3. And so the empirical formula for this compound contains 1 sulfur and 3 oxygen. And so that's the ratio, 1 to 3 ratio of sulfur to oxygen. So that's how you do empirical formula. I'll take you through maybe 2 more problems like this. Okay, now we'll look at this other problem. So this next problem is dealing with percents. And so remember, whenever you're given percents, just make them masses. So we'll say that the total compound has a mass of 100 grams, which means that it's easy for us to figure out the percents of each. So the first one, we have sodium, 60.8 grams of sodium. We have boron, 28.5 grams of boron. And lastly, we have hydrogen, 10.5 grams of hydrogen. So remember, same thing with the empirical formula. Divide by the mass on the periodic table. 23 grams for sodium, 10.8 for boron, 1 gram for hydrogen. Then the next step is solving these. So we get 2.64 for the sodium. We get 2.64 for the boron. And lastly, we get 10.5 for the hydrogen. So now what we're going to do, divide by the lowest value, the 2.64 for the sodium and boron are the lowest values. So divide everything by 2.64. When we've done that, what we have is this value is 1, this value is also 1, and this value comes out to be about 3.98 approximately, and we are just going to round that to 4. So the empirical formula of this compound is going to be Na, 1 boron, and 4 hydrogens. And that's how we solve that type of problem. We're going to take you through one more problem. Here's the last problem. Here we're told we have a sample of an organic compound. The compound contains carbon, hydrogen, and oxygen. It was burned in air to produce a certain amount of carbon dioxide and water. So, a couple things that we need to look at. First thing you may notice is we burn 0.537 grams of compound, but the masses of our products are actually higher than the amount of organic compound we put in. And so how can we explain that? The reason why we can explain that is when we burn stuff, we're actually, especially organic compounds, we're actually reacting with oxygen. So there's oxygen in the atmosphere. So the additional mass, some of the additional mass, or excuse me, all of the additional mass that comes from this is actually coming from the atmospheric gases. Okay, so so basically oxygen in the atmosphere. So here's how we're going to solve this problem. We're going to first figure out how much carbon and how much hydrogen we have in both the carbon dioxide and then in the water. So we'll look at the carbon dioxide first. We have 1.030 grams. We're going to use the law of conservation of mass, or excuse me, law of definite proportions, to say if I have this amount of carbon dioxide, I know that there's one carbon, which has a mass of 12, and then there are two oxygens, which have a mass of 32. So 12 plus 32 is 44. So the total mass of the carbon dioxide is 44, and out of that, 12 grams is going to be carbon. So I solve for that, and I get an answer of 0.281 grams of carbon. Okay. Next step is figuring out how much hydrogen. So I say if I have 0.632 grams of water, law of direct proportion says if I have 18 grams of water, which is the mass of 2 hydrogens plus 1 oxygen, I have 2 grams of hydrogen. Again, these values are just taking them from the periodic table and determining how many atoms of each type are found in there. Since there's H2O, multiply the mass of hydrogen, which is 1, rounded to 2, and then multiply that out. And if we do that, we're going to get an answer of 0.070 grams of hydrogen. Okay, and then once we have those two, we're then going to look at this. This is how we can determine how much oxygen we have. So if we take this value here, the 0.537, if of that 0.537, 0.281 grams is carbon and 0.070 grams are hydrogen, then what's the remaining mass coming from? And the remaining mass is going to be coming from the oxygen. So what we do is we can add these two values together, and we do 0.537. Law of conservation of mass says that we have to be accountable for the remaining mass. So we subtract 0.351 from that value, and we get 0.186 grams of oxygen. So now that we have grams of oxygen, grams of hydrogen, and grams of carbon, we're going to do the exact same thing that we did for the two previous problems. We're going to take our masses and we're going to divide by the mass on the periodic table. And so we have 0.281 grams of carbon. Mass on the periodic table is 12. We have 0.070 grams of hydrogen. Mass on the periodic table is 1. And we have 0.186 grams of oxygen. Mass on the periodic table is 16. So once we divide, those are the masses that we get. Or excuse me, not the masses at this point. They're not masses anymore, but they're ratios. So now we're going to divide by the lowest ratio. And this is actually 1, 2. So divide everything by this value here, 0.012. Divide this by 0.012. Divide this by 0.012. Okay, and this value comes out to be approximately 2. Okay, this value comes out to be .583, which we're going to round up to 6. And then lastly, and this value may be 5.83 because I rounded some of my previous answers, and the last one is going to be 1. So we're going to say it contains 1 carbon, it contains 6 oxygen from this value here rounded, and, or excuse me, 6 hydrogen, if I said that correctly, 6 hydrogen, and 1 oxygen. So the empirical formula is CH6O. And that's how you solve this type of problem.